Okay, so we've got it, and if you do zoom 6, now you either here, if you need to hit zoom 6, if you hit 6, or if you just hit graph, then, because if I hit 6, it's going to go straight to my graph. So, one way or the other, you're going to get to your graph. Now, think about what you said a while ago, Caroline, just hit graph. Hitting graph won't do you any good if you don't have the equation in there. So, you have to, if you think through the process, like I said to you, what does f of x stand for? It stands for y equals, well, y equals. You're going to type something in. Even if it's some crazy x cubed something over x squared something. You're on the ACT and it wants to know, you know, is it defined for -1? Is it defined for -2? Now, a lot of times I actually graph it on my graph paper before I put it on my calculator. So let's go back to the graph paper and let's talk about some of this and we'll come back to the graph. So, vertex, did we know that? We should know that before we graphed it. What is it? 6, -2. Opposite of this one, same as this one. Now, let's talk about axis of symmetry. And I abbreviated A of S. Okay, axis of symmetry is on, well, I tell you what, hold on that. We'll come back to it. Let's go ahead and graph it, and we can use the graph to answer some of these questions. So, -6, -2 is to the left quite a bit of your y-axis. So I'm going to shift my axes over a little bit. I'm going to put my y-axis over here. I need more of my x-axis to get to that -6. And I'm going to go ahead and plot -6, 1, 2, 3, 4, 5, 6, -2. Hope I didn't hit the crosshairs. Okay, now the A was 2. So what does that do for me in terms of graphing it without a t-table? It means you go up. It opens up because it's positive. Up 2 and left 1 and right 1. And then we can eyeball it. Now, I tried something with my regular class yesterday and they didn't like it. I will show you. It's just, I like to just give you extra information that doesn't overwhelm you. But if you really want a good graph, I'm going to show you in just a minute a way to maybe make this even more specific, more exact. But I mean, if you're like me, I feel comfortable that mine looks like my graph. What is the concept of symmetry? What are we talking about when we say symmetry? Yeah, it's the same on both sides. With these, it's a fold line. It's very symmetrical. It's a fold line that would make it same on both sides. It is not part of the graph. You notice there's no line on this, but I'm going to put it on my graph dotted. And I think you would see that it would be that line right there. You do not have to draw this in your classwork. I'm only going to draw it on this one, but you still need to state it. Now, if you remember from Algebra 1, and we've probably mentioned it when we did lines, that horizontal lines are y equals lines. They are functions. This is an x equal line, and it is not a function. The axis of symmetry, when a parabola opens up, and we'll do later parabolas that open on their side, and their axis of symmetry is going to look like this. To me, it makes my graph look like a pitchfork. That's what I say. It's kind of got that pitchfork look to it. So, if you look at it, notice that your x is -6, if you count over, and every point on that vertical line has an x of 6, so the axis of symmetry is x equals -6. It's x equal, let me go back right here, it's x equal h, where h is the x of the vertex. Am I on screen? There you go. It's got to go through the vertex, and it's going to be a vertical line, so every point on that line is -6 something, and that's the axis of symmetry. It is not a number. People just want to put a -6 there. It's a line. Lines are vertical lines or x equal lines. Now, every parabola that opens up or down is going to cross the y-axis, and this is not one you can visually see it. And the reason why is this graph is going to keep going up and up and up and up forever and ever, way up, you know, infinitely. but what happens is it's going to cross off the screen. So we'll hold that thought for just a minute, and it's actually where, let's do it this way. It's going to be when your x is 0, because every point on the y-axis is 0 something. So 0 some number. You know, it's not 1. It's not even, what, maybe 10. You know, you can see this is going to keep going way up, but it's not getting very close to the y-axis. Now, x-intercepts, sometimes it has them, sometimes it doesn't, and we'll have that discussion in a minute. Intercepts are simply where it crosses or touches the x-axis. Does this one do that? And what are they? What are those points? There's one of them, and there's the other one. What are those ordered pairs? Let's see, y-intercept we're going to hold on to for a minute. And then x-intercepts, there's 2 of them. Well, I'll back up on that. I'll just wait on that. They're going to be on the x-axis, so their y is going to be 0. Now, often you just see them say x-intercepts are, and they'll just give you 2 numbers. But I always do this to make you realize they are ordered pairs. What are those numbers? What is that point right there? Yeah, if that's -6, one to the right is going to be -5. And what's this one? -7. They're not always, all the ones in your classwork will be integers. I think we have done how to estimate things and stuff. That's going to help us, especially when we do standard form. Your quadratic formula will help you a lot with some of that stuff. So I just gave you basic ones today. And what do we have next? Domain. Okay, remember, domain is your x's. Now tell me about the x's. Let's go to our x's, x-axis, and see what x's have y's. Will one have a y? You don't think so? Well, I tell you what, let's go to our graph. We'll go on to the graph, and I'm going to show you something here anyway. You have the trace feature. Let's go back to our notebook paper. You have the trace feature, which does something awesome for you, that when you type, we talked about it before. It's on a handout. I think I gave you a cutout, but I'm going to write it kind of layman's terms. Type any, excuse me, x in your window. I can't pick -20. It'll say, I think it says something like out of range or something, because we did that when we did lines. And then comma, it will give the y. Okay. Now, here's the ultimate thing I really like. When you hit trace, we're spending more time on this first one. The second one, the third one will go a little bit quicker. When you hit trace, it will, and I don't know any reason it doesn't, it will start on the y-intercept. So hit your trace key. There's your equation. Look, x is 0, y is 70. That's why I can't see it. It will give you y's outside of your window, but it will not give you, you can't put x's in outside of your window domain. So your calculator's domain right now is -10 to +10. So when x is 0, y is 70. That's where this graph crosses the y-axis. Some of them you see, some of them you can't. We're good with that. Now, what's nice about this is you can check some points that we just did. You can also think about it in terms of domain. If I type, now it has to be in trace mode, and as long as it's in trace, now remember you can use your arrows to go up and down. That's going to be approximate things. We want just nice, pretty integers. So if I type -6, just type it. As long as it's windows up, you're good, and hit enter. Now what did it give me? And what is that? That's the vertex, and look, it's blinking on the vertex. If I type -5, it should give me 0, and it's at that point, which is the x-intercept. And if you want to write this, the other name, singular, each one is a 0, or in this case, there's 2 of them. They're 2 zeros. But we're going to call them more zeros now because, look, it's when x is 0. Did we put them on here? Yeah, when y is 0. So -5, 0, and -7, 0. So sometimes you'll hear me call them zeros instead of x-intercepts. Did we put our y-intercept here? Oh, I put it up here. that wasn't supposed to go up there. It goes on this one. Here we go. Now, if I type in 1, is there a y? Yeah, it's 96. If I type in 2, now here's the question. Is there any number that you can't square? Can you take any number you want to, add 6 to it, and square it? Yeah, all reals. Oops, where are we? All x is all reals. We'll just say it that way. No imaginary, all real numbers. The domain on every parabola that opens up or down is going to be all reals because there's no x. Every positive number you can add to 6 and square it. 0 you can add to 6 and square it because you can type it. 0, it gave you 70. Negative 10, you can type it. It'll give you the y value. Now, what about the range? Now, look at your y's. What's the lowest y that graph goes to? Negative 2. So y is greater than or equal to negative 2.